What do we even mean when we say something has a dimension? Let's start with a single point in space. The actual point itself is considered to be zero-dimensional. Even though the point may have a coordinate location somewhere in space, the point itself doesn't possess length, width, or height. If we were to change the coordinate location even slightly to any degree of magnitude, we'd no longer be positioned on the point. We'd be at another point. The point doesn't take up any room in space. In contrast, a line does have a single dimension, length. In order to specify a point on the line, we'd need to use a real number to indicate where along the line the point lies. It requires the use of one coordinate or parameter value, hence one dimension. It doesn't matter how the line is oriented in space, or even if the line is in multidimensional spaces like 3D space. It's still an object that just needs one parameter in order to define the position of any point along the line. It might surprise you that this also extends out to curved lines as well. The reason I say that is if a line curves in some way, that would be spilling out into another dimension of space. However, just like in the case of the line, the extra dimensions around the object don't actually matter for its dimensionality. The thing that does matter is how many parameters we'd need to be able to describe the object. So even a curved line can still be fully defined using just one parameter. Another interesting example is a circle. A circle is different from a disk, which would include the surface points on the interior. Instead, a circle is just the points on the outside perimeter of the object. Interestingly, the circle is drawn on a plane, which we know is two-dimensional because it has both length and width. However, the points on a circle can be parameterized using only one variable, which again makes it a one-dimensional shape. Of course, if we include the interior of the circle, then we have a disk, which is two-dimensional. That requires two coordinates, both length and width. The cube has length, width, and height. In order to represent any point within the body of the cube, we'll now need three coordinates, and so it is a three-dimensional object.